Okay, so here we are for example 5, and this is talking about graphing from a verbal description. So suppose you get a problem where it's listing it in words. Basically, a linear function g models a relationship where the dependent variable increases 3 units for every 1 unit the independent variable increases. Graph this function when g of 0 is equal to 3. So basically you might just be saying, oh my goodness, I don't even know how to set this problem up. But let's start by talking about how it says this word linear. Since it's a linear function, g models the relationship with a dependent variable increasing every 3 units for every 1 unit the independent variable increases. In other words, this means we can write this in the form of y equals mx plus b. So let's take a look. When the dependent variable, remember dependent variable is y. When y is changing, the change in the y is plus 3. When the independent variable is increasing by 1, the change in the x is plus 1. In other words, the slope is going to equal the change in the y over the change in the x. And they tell you in this information, they tell you that the dependent, or the change in the y, is 3 units, and the change in the x is 1 unit. And they're both positive. It's increasing. Increasing is positive, and increasing here is positive. So that's finding slope. So the slope for this problem is 3, and that takes care of this first part. The second part says find the y-intercept. Well, it says when g of 0 equals 3. So that basically is telling me that this is the situation when x is equal to 3, because this really is my x term, when x is equal to 0. In other words, on a graph, if my x term is equal to 0 on my graph, and it's saying it's 0, and this is 3, well, that right there is my y-intercept. Okay, so that's my y-intercept. My y-intercept for this problem is 3. Okay, so I have my slope and I have my y-intercept, and then finally it asks me for my x-intercept. So using the same method which we just did before, if I go down 3 and right 1, okay, I'm just going to fill in my graph. So my slope is 3 over 1, so I go, down 3 and left 1. 1, 2, 3, and left 1, or up 3 and right 1. Okay, that's going to fill my graph, because I could really rewrite my slope as -3 over -1. So you could either say I rise 3 and go right 1, or I go down 3 and left 1. And it has to be negative over negative to make it a total of a positive. So when we look at our graph, it looks like that. And in fact, my x-intercept in this problem is -1. So that's the third part. So my 3 parts are slope, which is 3, y-intercept, which is 3, and x-intercept. Hey, how about that? X-intercept is actually -1, not 3. Just kidding. All right, so that is example 5. Okay, so now we go to example 6, which is solving a real life problem using slope-intercept form. So I'm just going to pull this up. And again, you don't have to copy this whole problem down. kind of defeats the purpose, I think. But you always have it here. You might want to take some notes on it. The first thing I want to do is I want to cube this problem. So the first thing is to circle the important information. So the important information, circle the numbers, circle any numbers you see. So this is really important, right? This guy. Circle, and I don't see any other actual numbers in this. So I underline important information. A submersible that is exploring the ocean floor begins to ascend. Okay, so that word ascend is really important. Okay, that means it's going up to the surface. And then the elevation, h in feet, is important. It's modeled by the function. That's important. T represents the time in minutes. Since the submersible began to ascend. Then we box our questions, right? So we know these are my 2 questions I have to answer. So let's take a look at the important information here. So we have this equation, and the first thing it says is to graph the function and identify the domain and range of this function. So the very first thing we have to do is draw a quick sketch of our graph. So just looking at this problem, you're going to be able to see here that the y-intercept is starting at a negative amount. So looking at this equation, this is my y-intercept, negative 13,000. So that's going to come down somewhere down here. So I'm going to start my graph here at 0, 0, 0. So if I were to extend this, this is how my x and my y-axes would look, right? Okay, but I'm starting, it's going to end up in this lower quadrant here because we're only going to go from negative 13,000 and all the way up to 0. That's really as far as up as we need to go. So we want to know sea level because that's sea level. So I'm going to count here by 2s. This is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I'm going to count over here on my y-axis by negative 2,000. So because we have to go all the way down to 13,000. So that's negative 2,000. This is negative 4,000. Negative 6, negative 8,000. Negative 10, negative 12,000. And negative 14,000, negative 14, and negative 16,000. So this is going to be right in the middle here. That's negative 13,000. That's my y-intercept. I'm sorry. Yes, my y-intercept. That is negative 13,000, which is the y-intercept. Okay, so that's the point we plot. And now using this idea of slope-intercept, it says 650 t. That means I'm going to rise 650 and run 1. So you're going to just keep entering these things in order to graph this. Okay, so we are going to plot it and graph it. And basically, another way we could check this is to find my x-intercept like we did the other day. And that would be when y is equal to 0. What is the x term? So if this is equal to 0, and we can just solve that over on the side, right? I'm going to just solve it so I can find my x-intercept. If I have 0 equals 650t minus 13,000, I would add 13,000 to both sides. And that's going to leave me with 13,000 equals 650t. Divide both sides by 650 or multiply by the reciprocal. And that leaves you with t equals 20. So basically, this is my my x-intercept is 20. That's what that means. And then when you, connect, I'm just going to use, I just have a box here to show you the straight edge. I forgot my ruler. You're going to connect those two dots. That's a quick sketch of the graph. Okay, sorry, it's a little messy, but you get the idea. So that's my graph. So the question now is to define the domain and range, and we really only want to know when it goes to this point. So this isn't necessary to draw the arrow, sorry. So my points go from here to here. So my domain is my x values. So the lowest possible x value I can have is 0. So my domain is from 0 is less than or equal to x, which is less than or equal to my highest x value, which is 20. The range of this graph, my lowest value on my y is negative 13,000, is less than or equal to y, which is less than or equal to 0. So that's my domain and my range. Okay? All right, so that's part A. Part B says to interpret the slope and the y-intercepts of the graph. So let's take a look at my slope. My slope in this problem, based off of the equation, I'm just going to rewrite the equation down here. So this is my equation, so this is part B. My equation is h of t is equal to 650t minus 13,000. The y-intercept is the beginning part. That's where we're starting. Okay, always the y-intercept is where we start. So it is when the elevation at 0 minutes. This represents the elevation at 0 minutes, or the elevation at the beginning, at the start. Okay? That's what this y-intercept represents. The slope, on the other hand, represents the ratio, the rate. It's the rate of the ascend. So basically, this is going up at a rate of 650 feet is what's being represented by my y-axis per minute. In other words, this is the rate at which the submersible is ascending. Okay? The x-intercept represents the amount of time. So let's write that. The x-intercept is the amount of time it takes to reach sea level. The y-intercept represents the distance when the time was equal to 0. So that's basically how we can interpret these two things. Okay, so please now take a look at the monitoring progress problems and see if you can complete those problems from the Google Classroom.